Hello, this is Chapter 8 presentation. I want you to look at your objectives again. It would be these things right here. So, the first one, discuss the 7 types of section views and discuss the concept of depth, height, and width and aux views and sketch objects using orthographic projections, section views, and auxiliary views. So, let's talk about section views. Okay, so why do we use section views? To document the design and manufacture of single parts that are manufactured as one piece. To document multiple parts that are assembled or built, like an assembly drawing. Or to help in visualizing the internal workings of a part or design. So to make a section view, first of all, we have to have a cutting plane. That's shown right here. So we'll have an object view here, right here, and then we'll draw a cutting plane, and then here is our section view. And then the section view is actually a projection of the part onto the cutting plane. So visible edges. So what we see now is we now have visible edges now that we can show. Now these would have been lines that may have been hidden on this view from the right-hand view, but now since it's a section, these are visible lines. And then we're also using cross-hatching, where that's the section lining. So section lining with cross hatches. Now where do we put section views? Well, in this particular case, let's say this could be a front view, for instance, and then this would be a right-hand view. So in this particular case, the section view can replace the standard orthographic view. That's a good idea for a cylindrical part just like this. We can replace that front view, which when you think about it would have all kinds of hidden lines and stuff in it, with the section view. And what that does for us is allows us to completely dimension some of these features on here fairly accurately, and we don't have just a jumble of hidden lines, because that's what this would look like if it was a regular orthographic view. But in this case it's a section view, and it's going to help us clarify the definition of the part, which is really the whole purpose of this course. Next, talk about labeling cutting planes. In this case, we have 2 different sections. We have a section AA and we have a section BB. And we notice that when we're taking it, we're going to label these cutting planes AA and BB, just as we're shown here. Okay, so a little bit about rules for section views. This textbook, and you're going to see this a lot in this class, is we're going to put these displays out here. So good examples of right versus wrong ways. Okay, so here we got a cylindrical part. It's got a section view, and here looks like a example of a good cross section. Now let's talk about examples of some bad cross sections here. Look at this one up here. We didn't show the visible lines that were made visible when we took the cutting plane. That's poor. It looks kind of like these features are floating out in space. That's really not the case. The other thing we do is we omit hidden lines in a section view. Okay? We don't put these hidden lines in here that define the geometry back here. We don't do that. The other thing that's wrong would be to use dash lines. Never use dash lines bounded by never hatch. Your cross hatching should never be bounded by a hidden line. That's just wrong. And this is a single part here, so if you notice the hatches on this side and this side, they go in the same direction. What we did over here, we changed the directions of the hatches, but it's the same cut, so that's wrong too. On a single part, a hatch is never crossed by a visible line. Okay, so these are examples of poor section views, and this is an example of a good section view. Okay, cutting plane styles. Okay, in a lot of cases, your software is going to be taking care of this, and I really don't get too picky about the size of your arrowheads and stuff. And if you've taken customizing AutoCAD, you have some control over this. But if you're using Inventor or something like that, the styles are pretty much dictated by the software, and really, again, unless something's really drastically wrong, I'm not going to be taking points off for styles, but I just want to make sure you know that. Okay, this slide is about visualizing the cutting plane directions. Like say, for instance, this has to do with the way these arrows are pointing on your section break. Okay, so in this case, the arrows are pointing to the left, which gives you a right side in section. In this case, the arrows are pointing to the right, and it gives you a left side section. And let's see. Next, we talk about the different types of section views. This is objective number 4. Discuss the 7 types of section views. The first one is obviously the whole section. That's kind of what we were taking right here. This is a whole section. You cut the whole thing section. Over here we have a half section. Okay, so first is whole section. The next one is a half section. Okay, so a symmetrical object can be shown effectively using a special type of section called a half section. It exposes the interior of half of the object and the exterior of the other half. Again, we would do something like this if it provided an enhanced level of clarity on the part. That's why we would do something like this, is a half section. Next one would be a broken out section. In a broken out section, we are just trying to show the detail of a little feature up in here. So we don't need to section this whole part completely. We just want to section enough of it to show this feature. That is a broken out section. Now this is a revolved section. Okay, in this case we're talking about a spoke of a wheel. And then we're also talking the rim of this wheel as well. And so what we're doing here is we broke the spoke out and we rotated the section so we can define what the geometry of that section is. That is a revolved section. So if you're counting along, the next one is a removed section. So far we have 1 whole section, 2 half section, 3 broken out section, 4 is revolved section, 5 is going to be a removed section. Now what we do in a removed section is we've taken the part is one that's not direct projection. Okay, so it's not a direct projection. Okay, it's something that we put somewhere else in the drawing to give us a detail of what the part looks like internally. So essentially what we've done is we haven't included this in the direct projection, orthographic projection of the parts. We've created a separate detail to show that removed section. Okay, and then the next one would be the offset section, in which case what happens here is that section break line comes through several different planes to cause to show features better. So in this case what we're going to do is we're going to show a cross section of this slot, and then we're going to shift the section break over to show the internal features of this hole here, and then we're going to shift it back over to catch the mounting holes. So that is an offset section used with complex objects, and we're not showing the section in a straight line. It's offset or bent, and that gives us an offset section. This one comes into a thing about ribs. Okay, in this case we've got this section AA is taken through this rib. Again, this is a special case though. So we got AAs cut through the rib. The proper way to project that is by showing the web in the rib and not necessarily the whole section. Again, this is a style points thing. And then finally, align section. So in this case, you're aligning the section view to show the features that you want. It's kind of like the offset section view, but again, we're taking an aligned view. And again, it's to clarify and to be able to show features. Because if we had taken this whole section through here, we'd end up with a funny view of this part on the side, and that's really just not the case. I'm going to stop this one here, and there'll be another one to finish this.